last time. We were looking at basic loops. You have a basic for loop and a basic while loop, and they have the same structure as both C and Java. They just have different syntax. For example, instead of the idiomatic for loop of the initialization, the continuation, and the increment condition, you have to use this for this thing in this collection iteration kind of pattern. Where if you just want to straight up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, well, one less, then you would use range. That will give you, by default, that will give you integers starting at 0, going up by 1, up to, but not including whatever the last value, this value is that you give it here. It has other optional arguments here. So if you give it 5, 10, it starts at 5 and then goes up to 9 by 1. If you give it 3 arguments, right, that third argument is kind of like the idiomatic for loop, right? This is very much an idiomatic for loop here, right? That's where you begin, that's where you go until, and then this is what you go up by, right? And it's just that the defaults are the most convenient defaults here, starting at 0 and incrementing by 1. That's what the single argument version is for, right? Then you have, of course, a while loop where you have to control everything yourself. And you have a little bit more control on that than you do with a for loop. But generally, the Pythonic way of doing things, remember we are online, so if you have any questions or if you're following along, the one of you that's following out, watching out there, you can go ahead and post to the YouTube chat and we'll see it. Otherwise, generally what you do is you work with collections. Python does not technically have arrays. Now, under the hood, everything is implemented using arrays, but instead, Python has lists, right? These are ordered collections of things, right? So there is the concept. It's 0 indexed, right? The first thing is at index 0. The second thing is at index 1, et cetera, et cetera. Oops, yeah, right here. Okay, and it has sets, right? Or unordered collections of unique elements. Just like we have in Java, we have sets there as well. And then what Python likes to call dictionaries. Dictionaries, right? These are maps mapping in either integers and or strings to other elements, right? And those are definitely the most versatile. But we will go through each and every one of these, right? Let's start out with lists first, all right? So lists. Lists are denoted using the square bracket notation, right? That is in contrast to arrays in C and Java that are denoted using the curly brackets if you want to initialize it like this, right? You can iterate over any collection using that regular old for loop. For x in numbers, right, it's going to print out x, right? And I've got 5, 7, 3, 4, 0, and 1 and 2 here, right? You can add stuff, right? So how many people have a Python background already? I'm going to be relying on you, you folks. I think that you can append, right? 42, right? And that will add it to the end of the list, right? And you can also print the entire list if you want in one shot rather than in a loop. What's going to happen here, though? Right? Oh, okay, it does work. All right, it works natively. Otherwise, there's what I was going to show you is something else. You can import pprint, right? I always do this. It's a pretty print stuff. The first P stands for pretty, and so if you want to print it instead of printing it like this, you would go pprint.pprint, and it would print it almost in exactly the same way. It's just that. But if you have other things like a list within a list or something like that, then it would pretty print it, and it would print it nicely. Okay. By the way, there it is, appended. There's at the end. What about inserting something? Anybody know? What if I wanted to insert it at the beginning? Whoa. Sorry. You know, many years ago when cell phones were new, we would have, probably experienced this in high school or something like that, where instructors would get all irate and the first time their phones rang, then that was the end of it, right? We're way past that now, right? Everybody has a phone. Everybody uses a phone now. I appended something at the end. What about appending something or inserting something at the beginning? How would we go about finding, how do I do that? Python, insert element list, right? Google is your friend, right? Everybody knows this. Insert, right? You can insert at an arbitrary location here. That's going to be an index and then whatever you want to insert. So for example, if I wanted to insert it at the beginning, numbers.insert 0, and then I'll go ahead and go with 101 there, and then pretty print that. Right? And you'll see here that 101 is now at the beginning. If you want to insert it in an arbitrary index, okay? What happens if you want to insert somewhere else that doesn't exist? For example, I don't know how big that is, but let's go ahead and go with the -1 here and make sure that it's different so that we can see a difference. Is that going to work in C or Java? Not at all. That's not an index anybody has ever heard of, but over here in Python, it works perfectly well. What did it do? It didn't insert it at 0. -1, where did it go? Went to the other end, right? And it inserted there, right? Right? Why would it be right there? 120. I thought it would, no, because otherwise 0 is going to be at the beginning. Otherwise, you can, it always wraps around. So you can have negative index values. All it's going to do is it's going to wrap around to the beginning of the list or to the end of the list, respectively, right? So you can do stuff like that. You can probably do it arbitrarily like this. I've never actually tried. Let's find out. Yeah. So if it just wrapped around a whole bunch of times and then ended up somewhere, -100, right? I'll leave it as -1, but negative indices wrap around the list, ... Right? What if you want to remove something? You pop it, right? So numbers.pop. And that'll actually return the value too. So x is equal to that, and let's go ahead and print those out. Print x and print numbers. We'll see that it's been popped out. Which element has been popped out though? Right? It's going to be that 42 at the end. Right? Popping always works at one end, by default works at the end of it. And this is because you can use it as what's called a stack that we'll get into later on. A stack or a queue. Pushing and popping. Well, you've heard of those terms before, right? Because of the call stack. When you make a function call, what happens? You create a stack frame and you push it on top of the stack, right? When you return from a function, that stack frame gets popped off the stack. And so there is a push operation, I think. Maybe not, maybe I'm wrong. But otherwise, it's just append. It's probably just append and then pop. You can pop, remove, from an arbitrary index. You can pop it using x is equal to numbers.pop using an index, whatever is the 4th element. Why do I say 4th element with 3? Because it starts at 0. 0, 1, 2, 3. And so this will actually remove, what would it remove? Oops. What is the 4th element there? 1, 2, 3, 4, 3. It'll end up removing 3. It's just a coincidence that I use 3, right? There we go. 3 is removed. Okay. Putting stuff in, retrieving stuff, right? Just retrieval. Retrieval is index based. So if you just want to get, say, x is equal to numbers sub 4, right? That's the 5th element. Print x. At that point, what's the 5th element? An excellent movie, right? Other than an excellent movie, I should say, right? What's going to be the 5th element? Excuse me, right? I think I said that, right? It's going to be 0. It's that 0 right there. Okay. All right then. Your weekend homework is to watch that Luc Besson film, 5th Element, if you've never seen it before. All right. So retrieval: put stuff in, take stuff out, retrieve stuff without taking it out. You can also delete stuff. Well, you can by taking it out. So those 4 basic CRUD: create, retrieve, update, and destroy. Okay. What about sets? Sets numbers is equal to. Let me go ahead. First of all, before I do that, let me go ahead and go all the way up here and move this into the notes so that you have it. Right. There. And let me denote this as Python. Right now it's just gray. But if I denote it as Python, it becomes nice and pretty. Right. Code syntax highlighting. So syntax here is going to be curly brackets. Right? Why? That comes from mathematics. If you're taking 235 right now, you are either into or you will be getting into sets. You might have seen sets before. Sets use curly bracket notation. Right? So 2, 5, 6, 9, 4, 3. Right, there we go. There's our first set. Pprint, dot pprint. Numbers. There we go. And how will it print? There we go. It'll print as a set. So can you get arbitrary, and this is me crossing my fingers now, x is equal to numbers sub, let me get the first one, that 2, print x. I wonder if this is going to even work. Let's find out. No, why? What is a set again? A set is unordered. There's no such thing as the first element, the second element, the third element. Right? There's no indexing on a set at all because it's a set. Right? I made sure to put in the invalid because sets are unordered. Right? So I'll go ahead and get rid of that. Right? But let's go ahead and try to add something to it. Dot append. I don't know. Let's go ahead and append 42. And let's see if we can get that to work. Nope. So how do we add something to a set? How do we find that out? Python set add element. I think it's just add. Yep, it's add. All right, so it's a different interface. So not append, but because what does append tell you? Append says put it at the end. Is there an end? No, there's not a beginning, there's not an end. It's unordered. So add 42, and then that will work. There we go. Now, it just so happens that it was put at the end. That doesn't necessarily mean it's always going to be that way. In fact, if I did for I in range starting at 42 up to 100, and I add numbers dot add I, and then 42 at the end. Let's go ahead and get rid of that for a second. Let's find out. Is it going to be all ordered? I have no idea. Probably will. All right, there we go. Oh, by the way, pprint here printed it out vertically. Why? Because it thought it would be prettier. Why? Because it was a much larger data structure, or it was a much larger collection at that point. Right? So let me go ahead and get rid of that. Let's add 42, print it again. Let's go ahead and numbers dot add 42 again. Let's go ahead and repeat ourselves. Violate the DRY principle, don't repeat yourself. We'll go ahead and violate that. Observe what happened. Was 42 in there twice? No. Why? Because sets are unordered collections of unique elements. Duplicates are not allowed, just like Java. Okay? So duplicate adds have no effect. All right. So how do I remove something from a set? Python remove from set. Well, you have to first of all find the element, right? And so you can just remove that element. If you want to remove 42, or let's remove 2, say, numbers dot remove. The interpretation there is no longer that it's an index. You're not removing the third element at index 0, 1, 2. You are removing the element 2, right? And it works. It just happened to be the first one. So put stuff in, take stuff out, find stuff, and of course, you can still iterate over it, right? You can convert a list to a set, right? So foo is equal to 6, 4, 8, 9, 3, and let me put in 2 3s there just to show you that it works. Bar is equal to set of foo, pprint dot pprint bar. You'll see that it has been copied except for that duplicate, right? And it's now a set. 3, 4, 6, 8, 9, and you'll see that it's also unordered. I don't know. I don't think you should read anything into it. That the fact that it's also sorted, I don't think you should read anything into that. Right? Although I could be wrong. We'd have to read the documentation for that. You can convert a list to, or a set to a list. Right? So for example, foo is equal to 2, 3, 5, 7, just like that. Bar is equal to list of foo. and pprint dot pprint bar. And you'll see that it's going to be printed as a list. 2, 3, 5, 7. And now you can add in duplicates to that other thing. Right? To do deep copies, you need to bring in a library. Import copy. And I think it's copy.deep copy. And what I mean by that is, let's go ahead and make a list here. 1, 2, 3, 4. Right? And then we'll say B is equal to A. This is a shallow copy. B and A are the same list. So if I do something like a.append 42, and I pprint both of these things, oops, A and B, you'll see that they've both been changed. Come on. Right, they both have 42. Why? Because A and B are pointing to the same list. So if you want a deep copy, I think that this will actually create a deep copy, but I'm not sure. Let's find out. Deep copy, right? C is equal to list of A, right? And then C dot add 101, or not add, append. There we go. And let's print out A and C now. So if I make a copy like that, I would not expect A to have 101 in it, and it doesn't. That's another way of making a deep copy. Or you can bring in this library called copy, and then you can make deep copies. I should say that is a deep copy. Or you can go copy.deep copy of C. So D is equal to, right? Something like that. Let's just see if this runs. Yep, it does run. And believe me, that's a deep copy. This library is useful for more than just lists. Yes, you can get a deep copy just by doing this, but if you need a deep copy of a bunch of things that are objects as well, then you need to bring in that library to do it. Or you need to use constructors or something. Right? Those are sets. So, where is it? Sorry, Python, spelled it correctly. So sets, Python. All right. So the last thing I wanted to show you, as far as collections go, are dictionaries. Right? Dictionaries are maps that may map an integer or a string as a key to anything that is a value. Right? I'm going to break this up into 2 lines. There we go. So for example, the way that you do this is you still use the curly bracket notation, but you provide key value pairs. So for example, foo is equal to, I'm going to go ahead and map 0 to hello. Right? The string hello. 0 maps to hello. I'm going to go ahead and skip 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll go immediately to 10 here. World. Right? I can go ahead and be unordered about it. Go back to 5, and that'll map to 42. These are mixed types. A value can be an arbitrary value. It can be a string, it can be a double, it can be a floating point number, right? So 101, I'll map that to 3.5. Right? You can also use strings as keys. So hello, with a capital H here just to make it different, is going to map to world. There we go, capital W. Let's look at that p-printed. P-print. Foo. Oh, sorry. What was Python, folks? What was I forgetting the entire time? Comma, 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 comma. There we go. It's not just white space. In fact, oh wow, thank you, Python interpreter. Perhaps you forgot a comma? Yes, I did. It's being very, I don't know. If you were to interpret that as being from an American, perhaps you forgot a comma. Yeah, okay, it's a little bit kind, but if it was if you say that with a British accent, perhaps you forgot a comma, right? Then it is kind of rude. But there you go. There's our mapping, right? How do we iterate over that stuff? Right? Iterating over a dictionary. Right? And by the way, why do they call them dictionaries? Because it's kind of a dictionary lookup. I think it's a bad name personally. because a dictionary tells me that you only have words and then definitions of those words. That's not what this dictionary is, right? It's a collection of either integers or strings that are mapping to arbitrary objects, not just definitions, right? But otherwise, to iterate over a dictionary, you would say for key value in foo dot items. Python folks, tell me, yes, no? All right, so print. And I'm going to print this as a formatted string because what I want to do is I want to say that the key maps to the value. Let's find out. No. For key value? There we go. All right, it's not a colon. It's a colon when you use a comprehension, which we'll talk about here in a second. All right? So what is k, comma v? It's the key mapping to the value. Otherwise, iterating over key value pairs in a dictionary. You could, of course, just iterate over the values, right? Iterating over just the values. And that looks very familiar for value in foo, right? Print formatted, the value is equal to v. There we go. So you could just go with over the values, 0, 10, 5, 101, hello. Those are the ones that I put in there. What happened to 3.5? Oh, no, those are the keys. Sorry. Keys. Key. In foo. Key. How do you do values? You need to call a function to do it. Iterating over just the values. For val in foo.values is what I believe it is. And this should be key. Oops. There we go. Print value is equal to val. I don't think this is right. No, it is. All right, excellent. Got it right in my first try. Right. These are the things you don't memorize unless you're using Python on a daily basis for weeks and weeks at a time. I'll use Python for like a day, and then I have to remind myself of each one of these things, items, and then the keys by default, and then the values for the values, right? But if you're iterating over the keys, of course you can get the values, right? Key is equal to key, and maps to value here would be key, what is it, foo of key. I don't think you can do this. I don't think you can, yeah, you can. There we go. So you can, you would use the key as an index, right? And you can also use that in an F string, a formatted string. Right? Or you could, of course, say value is equal to foo sub key. Right? Very, very, very useful maps, right? In fact, that's probably what you're going to want to use, right? Lists have their usage, sets have their usage, but by far the most versatile is going to be those dictionaries. So, dictionary demo, Python. Now for something really Pythonic, which are like comprehensions. Comprehensions. Did I spell it correct? All right. A comprehension, I don't want to retype it because I'm going to get it wrong. A comprehension is a way to build a new collection. For example, and again, you might be in 235. Are you doing sets yet in 235 or 235H? Or are you just on logic or something right now? Logic? Okay. So you have the set builder notation. For example, it's something that looks like this. Let me go ahead and go with the numbers is equal to just some random numbers here. But I want a variety. 9. There we go. You can a comprehension is a way to build a new set. So for example, numbers plus 1 is equal to, I can create a new set and I can iterate through that old list and I could grab like 4, 6, 3 out of there, add 1 to it, and then put it into the new list. Or I could do it in a one-liner. X, where if for x, or let me go ahead and go x plus 1 for x in numbers. There we go. So do you see that syntax there? It's kind of like, it's what's called set builder notation in mathematics, or in this case, it's called a list comprehension. What I want is all the elements x plus 1 for each x in this up here. What is that going to look like? pprint numbers plus 1. Well, if it's 4, 6, 3, 5, and then I add 1 to it and put that into this new list here, what is it going to look like? 5, 7, 4, 6, dot, dot, dot. Right? That's what's called a list comprehension. And you can get really, really fancy. For example, evens is equal to x for x in numbers, and then give a condition if x divided by 2 is equal to 0. Right? Divided by 2, that's going to be mod 2, same in both languages. Right? And let's print that out. What is that going to do? It's only going to get the even numbers. Right? So there, 4 and 6. Right? What if you wanted the odds? Same thing, but is equal to 1 for a remainder. Getting those that are a positive, right? Positives. So let me just add one negative here to show you that it's going to be filtered out. If x is greater than 0. Right. Let me put in 0 as well, so to show you that they'll both get filtered out. There we go. There. Oops, for numbers, if x is greater than 0. Positives, positives. Oh, what's going on? Evens, evens. It was lagging, so it probably didn't get the saved file. There we go. I was correct the entire time. It was just screwing up there. 0 and that negative 42 are filtered out. Right? You can, I think, do, say, for example, numbers minus positives. Right? I think foo is equal to. Can you do this, Python folks? I don't know, is this valid? No, you can't do this. All right. Wishing for too much. I don't think that that would be right anyway. That you should be calling a set difference or something like that. Go ahead and look up how to do it. Sets, same exact kind of comprehensions. But let me go ahead and create a dictionary here. Right? Foo is equal to 1 maps to 1, 2 maps to 2, 3. Actually, do I want to do it this way? Yeah. Maps to 3. What if I wanted the inverse map? Bar is equal to a dictionary comprehension, VK, for K, comma, V in foo.items. What's that going to do? Let's pprint bar. What am I doing there? We've already seen this. For the key value in that dictionary, what am I doing over on this side? Value key. Let's see what that looks like. I just reversed everything in one line of code. Right? For simple stuff, list comprehensions, dictionary comprehensions are super, super nice. If you need to do anything more even moderately complex, you're going to be, doing somersaults in your head trying to figure out how to do it. Right? I really want to get this down to one line, right? And then it becomes frustrating because I know it can be done, but I don't know how to do it. And then you waste your entire. Whereas if you'd just written a traditional for loop and get it done really, really quick, you're going to be banging your head against the wall trying to figure out how to do it. So for simple stuff, great, use it. For complex stuff, your mileage may vary. What else would you want to do with that bar? I don't know. What? Bar is equal to key value pairs. For key value pair in that, if the value divided by 2 has a remainder of 0. So we're only retaining evens, there, 2, or odds or whatever. Right? It's a way of filtering stuff. It's a way of building new lists, building new dictionaries, etc. So it's very, very powerful. Right? You can make matrices, for example. How are you going to do it? Indices is equal to you can't do something like this, is what I should say, right? If I wanted to store 0 through 9 in a list, I would not be able to do something like this, pprint.pprint indices. I don't think that this is going to work because that's an iterator. All I'm doing is assigning the function itself to the variable indices. It's kind of like a function pointer in C, right? That doesn't actually get me a list of indices. But if this gives a function reference, not a list of 0 through 9. So you can achieve this using a list comprehension. So indices is equal to x for x in range of 10. And now that will be a list. Right. There we go, 0 through 9. Right. You can have pairs. Oh, really cool. Right. Python supports what are called tuples. So for example, a pair, I can go with 10, 20. I can go with a triple is equal to 5, hello, 3.5, right? All I'm doing is putting these in, surrounding them with parentheses here, right? What that's going to end up doing is it's going to end up creating a tuple. You can treat that like a list. The first element is going to be at index 0. So if you wanted to pull out the first element, you could go pair sub 0. You could go triple sub 2 and to pull out the last value. But it really is powerful if you want to just, I just need to put these two things together, or these three things together really quickly. You can do it with a tuple. And then you can use that with a combination of list or map data structures. For example, a square is equal to all tuples x, y for x in range of 10 and for y in range of 10. Right, and then let's print that out. Pprint square. I don't want to go that far because that's going to be a lot. Let's only go 5 and 5. Right? So this will end up doing basically a 5 by 5, kind of like a matrix, but you're using tuples as your index instead. All right, so let's print this out. And you'll see that all combinations, 0, 0, 0, 1, 0, 2, 0, 3, dot, 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 1, 0, 1, 1, 1, 2, dot, 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 et cetera, et cetera. Right? Really cool way of doing things. So for example, if you wanted to do a matrix or something like that, or you had a loop within a loop, one other way that you could do that is by generating these tuples. Then you only have to iterate over the tuples. So for x comma y in square, right? I don't know, whatever you want to do with it, right? Print x. Let's do this as a formatted string because I'm going to use and y. I almost exclusively use formatted strings, right? There we go. All right, pulling those out. Okay. So another really useful thing in combination with all this stuff is tuples. So comprehensions and tuples. That's one thing I really like tuples about Python. I wish more languages did it. Java attempted to add something to that. I forget what they were called. Probably just tuples, but they did it in a really janky way, where you're still forced to basically use well, yeah, they didn't do it well, in my opinion. Can you use multiple types, int and string and sets? Yes. That's called mixed typing. So I don't want to lose everything here. You can go foo is equal to 1, 2, 3, 4.5, 5.5, and hello. Right. Yep, you can use mixed types. Pprint, foo. Right. Not that you would necessarily want to. Come on. There we go. 1, 2, 3, 4.5, 5.6. You're just mixing the types in. Right? Why? Because it's dynamically typed. There is no list of integers. There's no way to enforce that. You can use type of, right? So x is equal to 10, right? And print type, I think it's type of x. Let's find out if that's true. Nope. What is it? Python type of, I think it might just be type. Where is it? Yeah, it's just type. Not of, but type. And this should print out integer or int or something like that. There's a class called int. And if it was 10.5, it would probably print out float. If we were to print the type of a variable, like if you give it to a function, which we'll talk about next, you can check, I expect an integer. Did you give me an integer? If not, I'll go ahead and do a or throw an exception or something like that. Good question. All right. Any questions so far? I can't believe I remembered all the comprehensions off the top of my head. It's because I didn't do anything complicated. Right. All right. I don't know. More on strings. Right. So a is equal to hello. Right. A sub, oops, I misspelled it. Lowercase h. A sub 0 is equal to h. Can you do that? You can do that in C. Can you do that in Java? No, because strings are immutable. Print A. Let's see if that even changes or if it even runs. It doesn't even run. Why? Because str object does not support item assignment. Right? It is immutable, just like Java. Once you create a string, that's it. You can't modify it. Right? So if I want to create, I meant capital H, right? I can go B is equal to hello, right? And that's a completely different string, right? I can make A point to B. That's a shallow copy. The old string is gone. But if I had retained that old string in a temporary variable here, I can still print them all out. Print temp and print A. They are completely different strings. Okay? So more on strings. Strings are immutable. Once created, they cannot be changed. All right, well, fine. A is equal to hello. I want to replace that lowercase h with an uppercase h. A dot replace lowercase h with an uppercase h. Right? And I'm just doing that for clarity. Those are still strings. They're not characters. And let's print out A. Is that going to work? Can I change A? No. In fact, I don't know if replace is correct. It's still lowercase h-l-o. Why? Because if you're going to replace something, it's going to return a new string, right? Because that's the only thing that it can do, because strings are immutable, right? And if I replace, come on, save, and then do it, there we go, right? So if you want to replace a sequence with another sequence, you can do something like this. Right? You can do substrings. All right, message is equal to hello, Nebraska. Right? Message dot Python substring. I think it's just substring. Free code camp is what comes up first. All right, yep. I'm just going to jump to the immediate syntax here. It is 0 index, so 0, 1, 2, 3, 4, 5, 6. I want just the character at index 6. So foo is equal to, and let's go ahead and print that out. If you want an individual character, you can do that, right? There's the capital N. But I don't want the individual character. I want everything all the way to the end of the string. Here's a cool way of doing it. From index 6, colon, all the way to the end of the string. That gives me Nebraska with an exclamation point. Right? This is really cool syntax. It works on lists as well. If you have a list of size 10 and you only want these last 5, you can go 0, 1, 2, 3, 4, 5, colon, and all the way to the end, and it gives you a new list that's a sublist of the other one, just with those 5 elements. Yes, you can provide another value over here. So 1, 2, 3, so 9. It is inclusive on the first one, exclusive on the the last one. So 6 through 9 would give me what? 6, 7, 8, 9. but it's exclusive on the other one, so on the second argument, so it'll only give me NEB. Right? Watch. NEB. 6 through 9 minus 1, just as all substring functions in most languages work. Right? What if you wanted the other way? What if you wanted everything up until 0, 1, 2, 3, 4, 5? So go up to 6. There we go. And print out foo. Now you just get hello. Right? So it's got two arguments. The first argument is the start point. The second argument is the end point, and you separate them by a colon. And guess what? You can do really weird things like message of whatever, one, whatever. There is a third, I believe that there's a third argument. I'm pulling this out of my memory here to do this. No. 0 to the end. There we, can I do that? Nope. Oh, save, are you saving? Okay. There should be another way. I think you go in 0 through 9 by 1. Oh, well, by ones, of course, duh. That's what nope. I thought that there were three arguments. Python folks, tell me, is this the first time you've seen this syntax? Oh, okay, it is? Oh, okay, never mind then. There's a way of doing it, I forget what it's called even. Python substring 3 argument syntax. There is a way of doing it. Come on. Oh, and by the way, you can use negative values here to start wrap around to the end of the string. Python trie implementation. No, that's not it. That's a data structure. You rarely use it, so forget about it. You hardly ever use it. But you can basically, like, I want every other character in there, right? I want to start at 0 and go to the end, but I want to go up by 2, just like a for loop or something like that, right? All right. What you can replace stuff. This can be a regular expression. You can remove stuff. I don't know, message dot remove capital N, and assign that to foo. I think you can do this. I'm pretty sure you can do this. Nope, you can't do this. Darn it. String remove substring. All occurrences of a substring is what I'm looking for. So remove all the E's or something. Well, okay, just fine. Replace all lowercase e's with nothing. It's that simple, right? There we go. Nebraska. There we go. Anything else on strings that you want to see? Otherwise, gee, I really wish I knew how to do this in strings. What do? Python, or Python tutor, not Python tutor, but Python string documentation. First of all, you're going to get a million websites like Code Bootcamp. You're going to get Stack Overflow. Why? Because Python is so damn popular that everybody uses it, including non-computer science students, data science students, whoever uses what is R, statisticians and stuff like that. And so you're going to get a lot of, but really you should be going back to the original documentation. What's the original documentation? Python.org, right? And you can take a look at all of these methods, right? For example, find, replace. Nope. Format, helper functions maybe? Cap words. String.split, there's another one. If we've got CSV data is equal to hello world, how are you? There we go. And I can split it. Foo is equal to CSV data.split. I'll split it along commas here, and then a pretty print, whatever I get out of that, pprint foo. I think it's going to be a list of strings, pprint foo. There we go. Yep. It separates them all out. So CSV data, what else do I usually cover? That's pretty much it. Is there a string builder? This is a good question. Mutable string in Python. I don't think that that's kind of not useful. It looks like byte array is what you want. Cat buffer. Yeah, byte array. We won't get into that. But in Java, you have mutable strings. It's called a string builder, right? Or a string builder or string buffer, right? And you can create a string temporarily, change it, muck with it, do whatever you want, and then finally dump it to an immutable string. If you could do kind of the same thing over here with a byte array, or you could just create new strings, and that's what I would generally do, right? But you can split CSV data, right? You can split not just on CSV data, but you can split on any arbitrary thing that you want. So that'll split on all O's, blah, right? You can split on combinations of things, so only O, comma, in which case there's only one token that does that for you, right? Let me go ahead and restore that. Well, I'll just go with O here. All right, 5 minutes left. Questions? No? Are you finding Python? Only 2 people were brave enough to say that they had prior Python experience. Finding it nice? Yay? Oh, whoa, okay. Oh, why is that?
I don't know. I can't get over the lack of curly braces.
Oh, okay, so it's a syntax punctuation issue there. My biggest gripe, of course, is going to be that it's dynamically typed. And now all the things that the compiler takes care of for you are now runtime errors. You can't write a function and expect an integer and enforce that at compile time. Instead, at runtime, you have to say, did you give me an integer or not? And if not, then I'm going to have to kick you out, right? And we'll get into functions here in like later. You can create a function, what is it, def hello or foo, right? And takes x and y, and then print x and print y, right? Now, if you expect x or y to be integers, you basically have to write code to do that. If a type of x is int or something like that, or something like this, I don't know what the syntax is going to be, but you have to, then we're okay. If it is not an integer, then we're going to have to deal with it, some way, right? And I hate dynamically typed languages for this very reason, because it changes all the things that the compiler takes care of for you, and it changes them into runtime errors. And now you have to either put it back on them. If you give me an integer, okay, I'm going to fail, and that's your fault. Or I'm going to have to do a bunch of type checking everywhere. That's my biggest gripe. But that's not unique to Python. JavaScript, PHP, Python, any scripting language is going to have that really ugliness. Right. All right. Then have a good weekend. I'll see you on Monday.